What's up, guys? Happy here. We're going to be going over 3.2 on the probability worksheet, and let's just quickly go over the question. So we were told that a lie detector is going to be 4/5 reliable when the person is guilty and 9/10 reliable when the person is innocent. If the suspect is chosen from a group of subjects where only 1 out of 100 have committed the crime, the test indicates that the person is guilty with probability. And let me read that. We know that 1 out of 100 have committed the crime. And the test indicates that a person is guilty. What is the probability that they're guilty? So going over like the notation I used here, right? I have G and T as my G and T as my events. So how G is the event that you have someone is guilty, and then T of G to indicate that the test is reading guilty, which is important because, as the question asks, um, what is the probability that the test indicates someone is guilty? That what is the probability that someone's guilty if the test indicates that someone's guilty? Keeping this in mind is really important for these problems. So let's proceed. I kind of just another thing with these type of problems, it's always good to write out your givens. So let's just go for those things. Well, the probability of someone being guilty is 1 out of 100 is given by the problem. Probability that someone's not guilty, just using the complement, is 99 over 100. And then the probability that the test reads guilty given that someone is guilty is 4 and 5, as given by the problem. And then the probability that the test is going to read guilty given that someone's not guilty is found via the complement rule with the probability that the test is not guilty or it's innocent for someone who isn't guilty. And by taking the complement of that, which the probability that someone is, the probability that the test is not guilty for someone who is not guilty, taking the complement of that as we do over here, yields us with the probability of 1/10. So with that done, now let's get back to the problem of finding the probability that someone is guilty given that the test reads guilty. We can start out with Bayes' rule here. Probability that the test reads guilty given that they're guilty times probability of being guilty over the probability of the test reading guilty. And we can expand the bottom using the law of total probability. So let's do that. That can be written out as the intersection of like the probability of being guilty times the probability of the test reading guilty given that someone's guilty plus the probability that someone's not guilty times the probability of the test reading guilty given that someone's not guilty. And yeah, just the intersection of guilty and not guilty for the test reading guilty gives us the total probability of guilty here over the probability of the test reading guilty given that they're guilty times the probability of guilty. And now we've kind of expanded everything out as much as we can. And now all we have to do is just substitute. So let's get to that. Um, probability of the test reading guilty when they're guilty is 4/5. Probability that they're guilty is 1 in 100. Here, probability guilty is 1 in 100. The test reading guilty and they're guilty by Bayes' rule, it's going to be the same thing as the numerator. 4/5. The probability that they're not guilty is 99 over 100. And the probability that they are going to read guilty and they're not guilty as we found above is 1 in 10. So I'm not going to do the algebra and simplify it out. Or not algebra, just I'm not going to calculate it, but the final answer is going to be 8 over 107, and that is 3.2.